structure. It's again one of the core structures in programming. In all high-level programming languages, we have repetition structures, and we have seen sequential statements, conditional statements, and now the repetition structure. Again, this structure exists in Python, in C, in Java, in C++, all high-level programming languages has it. So if you know what it is and how it is used, actually then you can just translate this knowledge to other programming languages. Learning other programming languages will be pretty easy. So then what is that? Well, for repetition structures, I will keep using this term loop, okay? So whenever I say loop, I mean a repetition structure. Now what is a loop? Well, in many cases, we might want the computer to do the same thing again and again. Like, look at this program, for instance. We have this turtle library, and then we want to say, turtle, move forward, then turn right 144 degrees, and then move forward again, turn right again, move forward, turn right again. So we want to do this for 5 times. So I can write it like 5 times, like it's doable. But of course, what should I do if it was 100 times? What it was 1,000,000 times? So should I keep copy pasting the same code again and again? That would make my code totally not readable. That will be a very long code, like 2 million lines of code, because each of them I need two lines. So the code will not be readable anymore. And well, it might be the case because, like, let's say that you are building an application for, I don't know, let's say Ministry of Interior, and then you need to do a certain action for each resident of Qatar. Okay, so there are roughly maybe, I don't know, 3 million residents, let's say. So you have to do the same operation 3 millions of times. Then should I really write the same code 3 million times? Well, that's not practical. That's not doable. And so probably we'll miss so many things. We'll do so many copy paste errors, so many things. So at the end of the time, it will not be readable. So therefore, we need some structure that will say the computer to do the same action for many times. Okay, so this is called the loop structure. So it helps us to make our code more readable. Like, instead of writing 3 million lines of code, I will just say, do this 3 millions of times. That's it. So I will be able to write in a much easier way. And for these loop structures, we will have these 2 cases: condition controlled and counter controlled. So what is this? Like, let's say that again. Now let's say I'm trying to build a robot. Okay, so it will move around and so on and so. And I can say that, let's say that it might take a step. Like, I would like my robot to move forward, but like maybe, I don't know, when we reach an obstacle, like I would like to say, okay, walk until you reach an obstacle, so that then you might turn right or left and so. So I don't know how many steps it needs. Maybe it is 5, maybe it is 3, maybe 10, I don't know. So, but I want to say that, okay, this is a condition controlled. Until there is an obstacle, there is no obstacle, sorry, move forward, okay? Or for the residents of Qatar, until there is no left resident that we didn't do any process, continue this process until you finish all of them. So maybe you don't know how many exactly you have, then you can just say it in this way. So this is the condition controls. Until there is an obstacle, move forward. But maybe in the counter control, maybe I know that, okay, you need to take 40 steps. Okay, so if I know that how many, then I can just say, okay, take 40 steps. If I know that how many students in the class, then I can say, okay, if there are, let's say, 40 students, 40 times do this operation. Okay, so I know that how many times it is. So then I can say now this is the counter controlled. And for these loops, we have two different loop structures, while loops, and then we'll see the for loop. So what is a while loop? So while loop is a condition controlled programming structure. So which means that the program will keep doing the same thing until the condition that we defined is true. So until there is no obstacle in front of you, so if it is true, move forward. Check again, is there any obstacle? No, then forward. Is there an obstacle? No, forward. Then if whenever you reach an obstacle, then you will not be able to forward, so you will stop. So this is the while loop condition. While it is true, while there is no obstacle, move forward. So I can translate it to English in this way. And each of these steps, I will call them iteration. Iteration is the code of block that you keep doing repetitively. So it doesn't have to be a single line. It might be like a multiple line. If you go to this part, for instance, for my turtle application, I'm doing this 5 times. And what is an iteration? At each iteration, it is moving forward and turning right. So this is one iteration. And then in the next iteration, it will do the same thing again. It will move forward and turn right. So whenever I say iteration, I mean that the code block that's been repeated. This is called the iteration. And what is the syntax of a while loop? Well, while is a keyword, so we cannot use it as a variable name, as a function name, and so. And then we use while, and then we write then a Boolean expression, like whether it should be true or false. Okay, the results eventually should be true or false, and then the double column, and then we write the statements. Again, check the indentation. So this indentation means the code that will be repeated. Okay, so I should again follow I should be consistent with my indentation. Like if I use, like in the if statements, if I use 5 spaces, then I should use 5 spaces for all statements for that code block, and then it means that okay, these statements will be executed repeatedly until the condition is true. So this is just a diagram showing how it is executed. So in a while loop, the program first checks the condition. Is it true? Yes. If it is true, then run the statements. And then check again. Is it true? Is it still true? Yes. Then run it again. And then check again. Is it still true? Yes. Then check again. Until if it is not true. So when we reach, okay, it is not true, it's false, then we will skip it. So of course, this doesn't like, so it helps me to, for instance, again, going back to my robot example, like I will say, check first, is there an obstacle? No, okay, then I can move forward. Is there an obstacle? No, then forward. Is there an obstacle? No. Then is there an obstacle? Yes, then I should stop. I cannot move forward anymore. And well, in some cases, well, based on our robot location, we might not run those statements at all. Maybe I started my program at this point. Like I didn't, the robot was here, and then we just started this while loop, and I'm checking. Wait, is there an obstacle? Yes. So I will not run this at all, and then I will just skip it and then move forward, move from this part. So in a while loop, those statements might not be executed at all also, like because at that point maybe it is false, so we will not run it. So basically these statements can be run 0 times, we might not run it at all, or we might run them multiple times. Do you have any questions so far? Then let's see one example. So here is a program, and here is how it is it's showing its execution. So we say that n is equal to 5. So we assign the value of 5 to a variable n. So we also do this here. And then we have this while loop. while n is greater than 0, okay? So we check n is greater than 0, and in our case, yes, it is 5 as of now. Then what we do is we will print n, okay, which means that we will print 5 for now. And then we will say for n is equal to n minus 1, which means that decrease the value of n by 1. So it was 5, but I reduce it to 4, okay? Then, so it was true, I print it, I reduce it to minus 1, I decrease it by 1, and then I check my condition again. Is it still, oh, wait a second. Is it still less than, greater than 0? Yes. So print again, decrease it again, and then check again. Is it greater than, so we'll print 4, then we'll print 3. Check again, it's still greater than 0. So print again and decrease it to 2. Check it again, greater than 0. So print it and then reduce it to 1. And then when we say 1, it's greater than 0. We will print it 1. We will reduce it to 0 here at this point. And then we will check it again. Is it greater than 0? No. N is now 0. So we will skip these 2 lines of code. And then we will come to here. So we will come to this part. We will come to this part. And we will print blast off. And then we will print n again, which is 0 here again. So for these actions, like, look at this, like I printed so many lines of code here, but for that one I just wrote this. So it's been just repeatedly, I've been running those statements. All right, it's 10:49. I think I should stop here. Thank you for your attendance. This is the class for today.